Assignment problem. Here 3 operators are there, 3 jobs are there. Timing of each worker job combination is given. One is time required to complete the job P by the operator A. 4 is time required to complete job Q by A. 5 is time required to complete the job R by the same person A. So, timing of each worker job combination is given. We have to assign each work to exactly one operator so that total time is minimum. So, the matrix is 1, 4, 5, 2, 3, 5, 4, 1, 3. First step is row minimization. That is subtracting smallest element of each row from all elements of that row. Taking first row, smallest element is 1. Subtract 1 from all elements of row 1. That is 1 minus 1, 4 minus 1, 5 minus 1. Second row, minimum is 2. Subtract 2 from all elements of that row. 2 minus 2, 3 minus 2, 5 minus 2. Last row, 4, 1, 3. Minimum is 1. Subtract 1 from all elements of row number 3. So, row wise minimization over. Next is column wise minimization. Similar procedure by column. Selecting smallest element of each column and subtracting that smallest element from the entire elements of that column. First column, minimum element is 0. Subtracting 0, we will get same column. Second column, 3, 1, 0. Minimum element is 0. Again, we will subtract 0 from entire element. We will get the same column. Last column, minimum is 2. Subtract 2 from entire elements of last column. That is 4 minus 2, 3 minus 2, 2 minus 2. Next step is minimum number of lines we will draw to cover all the zeros. Minimum number of lines we are drawing. For drawing minimum number of lines, I am selecting here 2 zeros are there. So, with a single line, I am covering these 2 zeros. Here also, these 2 zeros I am covering by single line. So, I have covered all zeros by 2 lines. 2 is less than number of columns. That is, minimum number of lines to cover all zeros not equal to number of columns or number of rows. So, we have to rearrange the matrix. For rearrange the matrix, we have to write the reason: the minimum number of lines to cover all zeros not equal to number of columns. Number of columns or number of rows. Number of rows and columns always will be equal. So, minimum number of lines to cover all the zeros not equal to number of columns or rows. So, we have to rearrange the matrix. We have not reached the final matrix. Now, we are going to make the final matrix. Steps to make final matrix. Here you can see 2 lines and you can see 4 numbers outside the line. After the 4 numbers outside the line, we have to select the smaller one. 1 is smaller one. Now 1 we will subtract from these all outside elements 4. That is, here it will become 3 minus 1, 2 minus 1, 1 minus 1, 1 minus 1. Then we will add 1 at the intersection of lines. Here you can see the intersection of two lines. So to 3 we will add 1. So we have selected smallest element outside. We will subtract 1, that is smallest element, from these 4 elements. We will add 1 at the intersection. Now these points at the line, there will not be any change. So we are doing the procedure rearranging the matrix. Smallest element outside is 1. 1 we are adding at the intersection. So 3 will become 4. 3 plus 1 at the intersection we are adding 1. 3 plus 1 4. This 0 will not be any change because they are on the line. Here also 2 zeros, no change because they are on the line. They are not at the intersection, they are not outside. So 0 0 will not change. Now these 4 elements outside we will subtract 1. 3 minus 1, 2 minus 1, 1 minus 1, 1 minus 1. So we got the new matrix. Here we will draw again minimum number of lines to cover all the zeros. If minimum number of lines to cover all the zeros equal to number of rows or number of columns, our matrix is final. So here for drawing minimum number of lines, I am covering these 3 zeros with a single line, 2 zeros with a single line, again 1 more 0 remaining. So number of lines equal to 1, 2, 3. Number of columns equal to 1, 2, 3. Number of rows equal to 1, 2, 3. So minimum number of lines equal to number of rows. Minimum number of lines to cover all the zeros equal to number of rows or number of columns. So we have reached the final matrix. Now we can do the allocation. For doing allocation, I am rewriting the matrix clearly without line. 0, 2, 1, 0, 0, 0, 4, 0, 0. Now our question was here 3 workers, 3 jobs. This was our original question. Since we have reached the final matrix, I am writing 3 operators, 3 jobs. I am going to allocate each operator exactly 1 job. So that total time is minimum. Steps for assignment. We are searching row wise. We start searching row wise single zeros. So here first row, yes, there is a single 0. Circle it. Since we are searching row wise, cut all 0 from corresponding column. 1 0 is therefore cutting. We are searching row wise single zeros. Once you circle the single 0, cut all 0 from the column. Again here searching for single zeros, no single 0, leave it. Searching for single 0, no single 0, leave it. Row wise searching over. Next we are searching column wise. First column, here no zeros because this already cut, this already allocated. Here 0, leave it. Here 0, leave it. So row wise column wise searching over, but zeros are remaining, assignment not over. So here 2 parallel sets you can see. Give assignment to anyone. Select any 1 0 randomly. Any 1 0 randomly you select. Then you cut all zeros from corresponding rows and columns. This 0 belongs to this row. Cut the 0. This 0 belongs to this column. Cut the 0. Select the remaining 0. Now your allocation is over. Wherever you are getting parallel zeros, select any 1 0, cut all 0 from the column, cut all 0 from the row. So this is remaining and this is remaining. So select these 2. Here we selected these 2. So A goes to P, B goes to Q, C goes to R. A is the operator, PQR are the jobs. AP combination, the timing is 1. AP timing is 1. BQ timing is 3. CR timing is 3. So BQ is 3, CR is 3. Even now your steps are not over, you have to add this. One more remaining. If any units are given, hours are given, you have to write hours. Rupees given, you have to write rupees. Okay, otherwise you write units. Minimum unit is 7.